All right, last page here. Number 13, we have from external point A. So we have a circle. We have point A that's shown outside the circle. We have two tangents being drawn. So one tangent line is there, the other one is down there. And it hits at points B and C. And it said chord BC is drawn to form triangle ABC. All right. If the measure of angle ABC is 66, so this angle here is 66 degrees, what's the measure of angle A? I don't know. But here's what helps us out. The hat rule, right? Two tangent lines from the same point outside the circle are equal. So that makes this triangle isosceles. And so that means that this angle is congruent to this angle, and this is also 66. So if we add these two together, 66 and 66, we're going to get 132. And this angle is just 180 minus that. And so it's 48 degrees. And that's it. Okay? That's all you're doing for that one. All right, next guy. Equation of the circle is given. What are the coordinates in the center and length of the radius of the circle? So this is our completing the square question. So first thing we want to do is make sure everything's grouped together. Get the x squareds and the x together. Get the y squareds and the y together. Move any other numbers over to the other side if they don't already complete the square. Second thing we're going to do is complete the square by doing b over 2 squared. So take the negative 6 divided by 2 and square it is going to give me negative 3 squared, which is 9. And then take the 2 divided by 2 and square it, which is really 1 squared or 1. And I'm going to add those two numbers and then 9 and 1 onto both sides. So this becomes x squared minus 6x plus 9 plus y squared plus 2y plus 1 is equal to 16. So I just took the b term divided by 2 and then square it. And I take this number and I add it on to the y's. I took the x b term, right, the linear term here, divided by 2 and square it, and add this number on to the x's. And then also gets added on the other side. So this is completing the square. So this is a perfect square, and it factors into, remember, that number in the parentheses before square. So this is x minus 3 quantity squared. This is factoring into the other perfect squared, which is y plus 1 quantity squared, and it's equal to 16, and there's my circle. So remember, it's supposed to be x minus h squared plus y minus k squared is equal to r squared. So if this is a negative 3, that means we plugged a positive number in here to keep it minus. We plugged a negative number in here to make it plus. Okay? So the center, take the numbers in the equation and change the signs, is positive 3, negative 1, and the radius is the square root of 16, which means it's 4. Okay? That's it. Number 15, remember, parallel chords create congruent arcs. So these two arcs are going to be equal. So if this arc is 130, that means that these two have to create that semicircle. So it's 180 minus 130 divided by 2, which is 50 divided by 2, and that's 25. So the measure of arc AC is just 25 degrees. All right, here's another tangent secant. So this is the segments rule. Remember, it's going to be tangent squared is equal to the whole secant times the outside piece. So this is 3, and this part in here is 15, which means that the whole thing is 18. And this is what we're looking for. So it's x squared is equal to 18 times 3. X squared is equal to 54, and we're going to take the square root. So at minimum, x is equal to the square root of 54. If we break this down and use your menu factor, right, number factor menu, F-A-C-T-O-R, you don't have to press menu. Just in the calculator page, type in F-A-C-T-O-R parentheses. Type in 54. It's going to tell you it's 3 times 3 times 3 times 2. Take out my set of 3's. This is going to equal 3 radical 6. Okay? That's in simplest form right there. And if you want to do the decimal, you are more than welcome to. 3 square root of 6 is equal to that guy. So Any one of those things is totally fine. And if you want to make sure that your simplification is correct, if you type in the original radical, did you get the same thing? That's how you can tell that 3 radical 6 is the same as the square root of 54. And then you're done. That's it. And that's the review sheet, guys. All right?